everyone! Welcome to our Scientastic class. I'm teacher Bridgeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together! Last episode, we learned about Isaac Newton, who is the proponent of the laws of motion. We discussed also the first law of motion, which is the law of inertia. Law of inertia states that an object at rest will stay at rest. An object in motion will stay in motion unless acted upon by an external net force. What do each short clips have in common?
They are all accelerating, ma'am.
Yes, very good. They are all examples of acceleration. Acceleration is the rate of change of velocity of an object with respect to time. It means acceleration has to do with changing how fast an object is moving. Today, we are going to learn about the second law of motion, and this is known as the law of acceleration. Law of acceleration states that the acceleration of an object is directly proportional to the net force applied on it and is inversely proportional to its mass. Acceleration depends on two variables. One is the net force of an object and the other one is the mass of an object. In simpler terms, as the net force applied on an object increases, its acceleration also increases. On contrary, as the mass of an object increases, its acceleration decreases. On the other hand, if its mass decreases, acceleration increases. Look at this figure. Which do you think has a greater acceleration? Is it a car or a truck?
Car, ma'am.
Very good. Car, which has a smaller mass, has a greater acceleration compared to a truck. I have here a picture of a full shopping cart and an empty shopping cart. If a person pushes the two carts with the same amount of force, which do you think travel farther and accelerate more?
Ma'am, the empty cart.
Very good. This is a real-life example of second law of motion. If the object pushed with the same force, the object with greater mass will have a slower acceleration than the object with less mass.
Yes, ma'am. I observed that when I accompany my mom in grocery store. At first, when our cart is empty, it is easier for me to push it and accelerate faster, but when it is loaded already, it's hard for me to push and its acceleration is slower.
Yes, that's a very good observation. This is the equation for acceleration. Force equals mass times acceleration, or capital letter F equals m times a. Capital letter F is the symbol for force. Newton is the standard unit for force, or kilogram meter per second squared, or we can read that as kilogram meter per second per second. M is the symbol for mass, and the unit we use is kilogram. Small letter A is the symbol for acceleration. We use meter per second squared or meter per second as the unit for acceleration. You can rearrange the equation to find A and M. In finding A, write down the equation F equals M times A, divide both sides by M, then cancel out M. Final formula for acceleration is A equals F divided by M. In finding M, again write down the equation F equals M times A, divide both sides by A, then cancel out A. The final formula for mass is M equals F divided by A. Or use the triangle method. First, draw a triangle, divide it like this. We have upper and lower part. We have capital F on the upper and small m and a on the lower. Use the figure and follow the arrow wherein F equals M times A. M equals F divided by A, and A equals F divided by M. This is a simple tip to familiarize the formula. Let's try this. You are pushing a 3 kg cart at a grocery store with a force of 3 Newton. What is the acceleration of the cart that you are using? To solve this, we are going to use GRESA. GRESA stands for G, given, R, required, E, equation, S, solution, and A, answer. Let's go back to our problem. Given 3 kilograms mass, 3 Newton or 3 kilograms meters per second squared, force. Required, A. Equation, A equals F over M. Solution, A equals 3 kilograms meters per second squared over 3 kilograms, cancelled kilograms. Answer, A equals 1 meter per second squared. The acceleration of the cart is 1 meter per second squared. It's your turn to answer this one. Answer, the amount of force applied to it is 7.5 Newton. How about this? Answer, the mass of the object is 0.5 kilogram. This is all for today, class. I hope you learned something. See you on our next episode. Bye!